We're going to determine from a graph the domain range and if it's a function. Oop, yeah, function. Let me try that again. Function. Okay? So what you're going to have to do is pay attention to how does your graph look? Does your graph have arrow caps, which means it's going to continue on its path? Or does your graph have dots? That means it starts here, it ends here. Okay? So that's one thing you have to look for. Before we get into that, we're actually going to take one of our situations from our notes yesterday, and we're going to graph it. Now, it seems like a weird one to graph. So this is going to be the third example we did with mapping yesterday about the groups of 3 kids and what was their favorite color. And remember, we had the one that was not a function. So we had Elena, Haley, Tony, we had blue, we had red, we had green. So here's a little review about mapping. You take the domain and box it. You take the range and box it. And mapping is putting an arrow from the domain value to its range value. So when Elena was asked what's her favorite color, she says, I like blue, but I also like red. And then when Haley was asked, she says, I'm just into red. And Tony says, green's my favorite. And you guys told me yesterday that this was not a function. And what made it not a function? Just anybody out loud. Yeah, Elena, that domain had 2 ranges, blue and red. That's what takes something from being a relation, or not being a function. It just makes it a relation. Okay, Cleo.
I forgot why the people were the domain.
That's just how it worked because she asked a group of kids. She had this group of kids that she was going to ask questions. It was their answer was the range. So if you think about it, you have an input. Cleo, what's your favorite color? You got the output is blue. Okay, so that's how they're working. I know it seems weird to put almost like a numerical value to a human, but wait, we're going to graph this, which is going to make it look really strange. Now, I'm going to graph this, and this is going to be, again, kind of an interesting graph because I only have one quadrant I'm going to look at. So we had 3 kids involved. We had Elena, we had Haley, or Hallie, and then we had Tony. And then we had 3 colors involved. We had blue, we had red, and we had green. And what I'm going to do is graph this. So Elena said she liked blue and she liked red. And then Hallie said she liked red. And Tony said he liked green. So, you guys told me, because of Elena, this is not a function. So, can you see something interesting about Elena's answers? What do you see that's interesting about Elena's answers? Rochelle?
If she didn't pick red, then it would be
Okay, I don't want to know about what if she didn't. I want to know, because she did, what looks interesting in this graph just on Elena, because we know she is the culprit here. She's the problem. She's the one that blew it for everybody else. So what's interesting about the graph of her choices? Kenny?
If it wasn't for the dot, the second dot in the red of Elena, it would have been a straight line.
Okay, but that's not answering my question. you're telling me how it would affect the overall thing. I'm asking specifically, look at Elena's graph only. What can you tell me about her responses that's different from everybody else's response? Kaleo?
There's 2 points on hers and everybody else's.
Okay. So she's got 2 dots. What if I connected them? What would I get?
A straight line.
Nope. Faith?
You would get it going like up, upside.
Okay, nope. We're only focused on Elena.
Or you would get it horizontal. Okay. Vertical.
Okay. Boy, that took a lot of work. If I could get on there. If I drew a representation of Elena's answer, because she made 2 choices for her, it's a vertical line. Okay? I could change Elena to 1, Hallie to 2, Tony to 3. I could change blue to 1, red to 2, green to 3. I could change these to numbers. The reality is, you don't get a function if 2 of the points can form a vertical line. Not a straight line, because all lines are straight, but they can form a vertical line. So there's actually a physical test called the vertical line test. The high school has referred to it as the pencil test because they use their pencil as being a vertical line. If you can lay down your pencil and 2 points, and vertically, and 2 points are underneath that pencil, then you don't have a function. So you can physically see function or not a function based on this vertical line test. So vertical line test, any 2 points that form a vertical line is the same as not a function. So anytime I have 2 points that are going to, in one column, form a vertical line, then I know I don't have a function. So that's going to be part of what you're going to look at the second page of this packet, is looking and answering, do you have a function or not? Okay, so you can use this idea of a vertical line test to very quickly say yes or no. Unfortunately, that's not where the problem ends. The problem now says, can you give me the domain and range? So we're going to do a couple of examples so you can see what it is. And there's going to be some graphs that are familiar and some graphs that are not. So let me get here graph paper. All right, so let's do something that looks, I'll do 2 side by side that are very similar to each other with one subtle difference, and it will change my domain and range. So x, y, 1, 2, 3, 1, 2, 3, 2, 3. So 2, 2, negative 2, negative 2. Okay. Look at how my shape begins and ends. Arrow caps or points? Okay, say it real loud, Jack. Points. A point says it starts here. The other point says it ends here. It doesn't go on forever. Okay, that makes a big difference. So what would be the domain? So domain, remember, are our x's. So how far left does this figure, which is called a segment, how far does it begin on the left side? Starts at negative 2. How far to the right does it go? 1. Does it include only integers, or does it include fractions and decimals? Okay. Why fractions and decimals? Okay, because if you notice the line goes all between the points. So the only time I would include individual points is if it was just individual dots. Okay? But far left to far right That's my parameters. So I could say real numbers, because that includes fractions and decimals, from -2 to 1. Now that word 2 says 1 is part of the answer choice. So real numbers means you also get the fractions and decimals. Okay? Range-wise, we're going to do the same thing. What's the lowest point that it hits? It goes down to -2. And what's the highest point that it reaches? It goes up to 1. Does it only include integers, or does it also include fractions and decimals? Yeah, all those little increments, because it's a solid line between them. So this answer is also real numbers from -2 to 1. Now, I'm going to replicate that diagram, but I'm going to make one subtle change. But it will have a profound effect on our answer. Now what do you see at the ends of our diagram? Arrow caps. How far to the left do we go for our domain? Forever, which is infinity. How far do we go to the right? Infinity. So that's all the numbers we know. So the answer is all real numbers. Okay, how far down does it go? Infinity. How far up does it go? Infinity, forever. So again, my range is all real numbers. Oops, forgot the real. Okay. Let me give you an interesting one. A couple of interesting ones. Let's do this one first. Oops, sorry, go back to black. Okay. Can anyone remember that shape? We kind of did half of it as an answer from, gosh, Monday? Tuesday? Tuesday? I think it was Tuesday. You guys should have learned this last year. He's called a parabola. That comes with an equation that has a squared term in it. So something that looks like this. Okay, this one happens to have more. In fact, it goes like this. So anytime you have a squared term, it's called a parabola. You'll get a parabola. Okay, so let's look at domain. So how far to the left is it going? Okay. What do you notice is happening as it's growing? Upward. It's going wider. Now, we can only look at a small portion of it, but this is going to keep going on and on and on and on and on. So how far left? Infinitely. How far right? So the domain in this particular one is all real numbers. Now, let's talk about your range, which is your up-down. Okay? How far down does it go? Oh, careful. It starts right here. Here's where 0 is. It starts there. Okay, that's how far down it goes. So it starts at 1. Okay. How far up does it go? Infinite. We don't know where it's going to end. So we could write it as 1 to infinity. So all real numbers. 1 to infinity. Okay. All right, let me do one more weirdo. This one you may have seen in your science class. This is a physics one. This one's a little trickier for me to draw. Oops, hold on. I did that bad. Try that again. Okay. Does anyone recognize that from science class? Okay. If you guys talk about sound waves, yeah. Okay, this is what they call a sine curve or whatever. The equation would be something like this. It's a trig function. So how far to the left does it go? Infinite. How far to the right? Infinite. So all real numbers is the domain for this one. How far down does it go? It should actually go all the way down. My dash for -2 is not where it's supposed to be. Okay. It goes down to -2, and it goes up to 2. So it's real numbers from -2 to +2. Okay? So that's the kind of thing that you guys are going to explore on that second page for your homework.